To introduce the leaf test, I'd like to start by just showing a version of the leaf test so you have kind of a little more idea of exactly what I'm talking about. Then I'll go to the board and I'll end showing a couple more samples. As I mentioned with the flour sack, so with this leaf, it's kind of the opposite of the flour sack. Here we're going to push lightness. And what you're going to have is a leaf fall down across the screen, being very light, and then hitting the ground. Very important, the idea that it has to be a windless day so that you're only dealing with the energy of the fall. There's no other aspect of, like, if a wind gust comes, that would change the whole dynamic of how the leaf would act. So, but with no further ado, let me play this. But the main thing you want to feel is the lightness of the leaf. And again, just like I said with the flour sack, it's all about the manipulation of your slow in, slow out, your timing chart. And again, like the flour sack, it's all about the relationship of the slow to the fast. Now, this test, where the flour sack is quite short, can be a bit longer. There is a minimum to the assignment. It has to be at least 4 seconds. But as you can see, this one's 8 seconds, and it didn't actually feel terribly long. So give yourself some time to work on this one. Also, don't design too complex of a leaf because you will have to be drawing that, up to possibly 100 times in your assignment. So yeah, so as this leaf falls, it's obviously falling in an arc. So that's really what you'll have to design, and where you get a lot of possibilities for variation in this test. And then that the leaf feels light as it falls. Um, so let me let this one finish. So notice how, it's about the slow versus the fast. So the slow is what's accentuated here. So it starts very slow with a slow acceleration rate, right? But look at that fast. That fast is key, and then it decelerates. So just like the slow was very important to the fast in the flour sack, the fast is very important to the slow in this leaf. And then as it goes into its apex up here, look at how cushioned, how much of a slow out there is going into the apex, and likewise a slow in after the apex into the next arc. Um, One thing to note too is how this one, what creates the arc or locks the leaf into the arc as it falls is its speed. So in other words, when it gets up here and it's in the slow parts, you can loosen it and let it have a little more of a free fall. At the end of this, when I show you a couple of samples, I have a really great example for that, and also maybe a problem example for that. But you'll notice this one, this gets slow, it feels a little soft in its relationship to its arc. But when it's in motion, it's really important that you lock into the arc. Um, yeah, okay, so let's look at the board. Okay, so when you first start designing your leaf fall, what you want to do is design a series of different arcs on the way down and have an idea kind of what you want to do. Like I said, after this, I'll show you a few more examples. I should say a couple more examples. But the one thing you don't want to do is have the same arc repeated over and over. There's a definite link to the arc you design. In other words, how it's falling, and the timing chart you're going to need. So if you design an arc that is just this to this to this to this to this, you're going to be doing the same timing chart over and over and over and over again. Be both boring for you to do time and time again. There's no new challenges, and it'll also be boring to watch. So you want variety. Also, just to be clear, what you want to do, the leaf, as the one I showed you already, can start at the top of the screen, but it needs to fall and land within the screen. Or it can enter the screen at the top. So you can start at the top, or it can enter from above, and then it's going to fall and then land on the ground. So you'll have to deal with all that. But main thing is, when you're designing your arc, try to find something interesting. So in other words, just different. So let's say if you do a long arc like this, maybe you want to do is a couple short ones, and then you can do a loop if you wanted, something like that. So there's variety. All of these based on just how long it is versus how, like I said here, how short it is, how subtle, right? This is falling slightly, rising slightly, versus a sudden quick fall. These will all ask for different timings. You'll have to kind of get the timing to work, making the test more interesting to watch, and I think more interesting to actually do. So the main thing to keep in mind as you do this, I would definitely say plan this all, have an idea before you start. For those doing pencil paper, on one piece of paper, draw it out, life size, as you're going to animate it. For those doing digital, your background layer. And then that'll be your set of arcs. with the idea that there is some, like these are assuming very sharp, no movement apexes, where you could have that idea where it comes up and floats a little bit, right? That you can't really draw this way. That you'll have to kind of plan a little bit of space for you to do that. But the thing about the leaf is it can kind of free fall a little bit until it finds its arc, and then it moves, in arc with speed, etc. But yeah, so the idea that like the acceleration rate is dependent on the arc itself. So let's say if you design this arc here, I'll just kind of draw this. Let's say it starts, say it comes in like this, comes off screen here. If it's moving across like this, it's not going to be any reason for acceleration. You need the fall to happen for it to accelerate. So here right now, if this was the spacing here, that'll be there. Now that's falling, I'll start to accelerate, but it won't be that much of an acceleration rate. It won't be so intense. And then it's falling all this way here. It's starting to level out. But usually what you'll find is you won't feel the slowdown till a little bit, until you start rising a bit. The slowdown won't start here. You want to start feeling the slowdown, let's say about here. And then on the way up, it can get really quite slow. Where here we have, 1, 2, 3, 4, 5 drawings of just the end of the cushion. Then on the way back down, right? Let me just move this over so that these don't overlap. It would be, this is a sharper fall. It's much more abrupt, so it'll be a quicker acceleration, right? And then that would keep going until, let's say it went like this, and then had a quick deceleration here. So the main thing is just getting these to all, your arcs, the falling and the rising, to getting your acceleration, deceleration in spacing, your slow in, slow out to match, so the weight feels right. So you can see where this one was like 5 or 6 drawings, even arguably was a 7, 7 drawings of cushion going into that. This one's much sharper and has 4. I guess I'm bad at counting. Whereas, if it were to decelerate something really mellow, that would be even more gentle. So let's say we're coming in at this speed. And then, like I said, you could have it where it kind of starts to fall, a couple things, and then go into another one. That's better to talk about. Like I said, I'll show you one of the samples. One thing I do want to bring up, since it's brought up quite a bit, loops. If you want to do a loop, that's totally fine. But I do want to just mention there are kind of 2 types of loops. One is the type of loop that just blasts through, meaning that it doesn't trigger slow and slow out. So let's say it's falling like this and does a real fast loop all the way through, and you're going real fast here. So if you just want to do that blast through loop, you're just going to keep your spacing essentially the same. But one thing you really have to consider is, and actually a very important point I should mention, is there will be no stretch at all. Definitely no smears on this. Stretches, and squash stretch and smears, etc. Those are all tied to ideas of weight or force. And a leaf falling, it might get kind of fast, but it never has force because it's too light. So when you're doing this loop, one thing you have to make sure is you have enough positions to actually articulate the loop. If you're really following your spacing, right, and I think about this spacing to here, and I want to keep this spacing going, that would probably put the next drawing here, but the eye won't feel, if you don't have any drawings over here, the eye will never get a sense of it moving over there. So if you just went from this, the arc you're actually creating is just going to pop to there and then keep going this way. So you need at least one drawing here. And this is where you might want to force your spacing into something that you have a little leeway here, into something that kind of, maybe you want a drawing here and a drawing here. It's technically slowing down a little bit. Let's get rid of this one. And now we put a next drawing here, right? So I have 1, 2, 3, 4 positions. And then our eye will feel that loop. So the blast through loop, you just have to be mindful and make sure you have enough positions that the arc of the loop actually gets articulated. All right, kind of ran out of paper, but finally, that slow in, slow out arc. Let's say you're coming like this, right? Let's see, that's the arc. Slow and slow out arc, of course, is that it doesn't just blast through. It kind of comes in, slows out. There's a couple things you have to keep in mind here with that, is that obviously the vertical, that's kind of always the structure of gravity, is at the vertical. So that as it's coming here, And the other thing you always have to be very mindful of with spacing is that in this case, once you start slowing in, you get locked into it. So once you start a slow in process, and this applies to slow out as well, the eye starts to expect you follow through with that slow out. So in other words, as you start to slow in, you have to be mindful of how far you have to get before you can speed up again, right? Because you have to start the process. The top here of the ball of this loop, excuse me, is not falling yet. The top is actually at the vertical, right? So just like here, the bottom is, sorry, at the horizontal. The bottom is at the horizontal. So there's no change of speed here. You have to kind of get to this part going up where you maybe start the possibility of slowing out. And then you can't start the slow in, speed up until roughly about here, in this case going counterclockwise. So you have to basically get to this area, have to organize it, you have enough speed to get to that area, and then you can actually make a cross. Otherwise they'll slow in and want to fall like that. So obviously go into this with enough speed, let's say we're here, and then plan it so, and this is where you know how you start the slow one, you have a little wiggle room to kind of push it. You're not entirely stuck by a true physics. You have some space. So, but once you really start, once I go from like this to this, these are kind of even spacing. But once I start that slow in, the eye is going to start to expect it. So basically, don't start the slow down too soon, right? So now make sure you get past here, and right now you can see the rate I'm using gets me to here. I still can go to about that far, and then here, and then this is probably going to start. Now I'll start speeding up, and then I'm fine. That's the main thing to think about. So the blast through is just about making sure you have enough positions to articulate the actual loopness. With this, it's about making sure you get past the vertical in your loop so that it will make its full loop. That's it. All right, let me show you a couple more samples and then you should get to work. Okay, let's end by looking at a couple of tests with that idea of that I was talking about on the board, about in the slow parts of at the apex of the leaf falling, the ability for a little bit of free fall, a little bit of organic fall. What you'll notice comparatively through the two tests I'm going to show you is if you overly stick to the arc, especially in those slows, it gets kind of mechanical, almost looking like it's on a roller coaster, like on a track type of thing. So getting a little loose at those areas, at the slow parts, that allow the leaf to kind of essentially fall out of arc, will give a more of an organic sense. So here's a good example of that. And here getting a little bit into the idea of the physics of a leaf falling as opposed to just kind of a cold analysis of using spacing slow and slow out, is realize, you know, when you're dealing with a leaf, it's not, there's gravity obviously at play here, but aerodynamics is at play well. So when the leaf, and you'll notice this when it's in arc, it's pointing with its own arc, right? So right here. But then if its shape kind of gets, and as it, excuse me, so as it points to its arc, it kind of cuts through the air. But if the shape kind of starts to kind of be at odds with its direction, you start to get a wind resistance, and that's what you see getting messed with here. This is a little more advanced take on the test. My concern of this test is ultimately your use of slow in, slow out. So you're welcome to kind of dive into this side of it. It will definitely make a better test overall. It'll look better in a portfolio type of thing. But you're also, if you're just still struggling with basic slow in, slow out spacing, maybe it's biting off a little too much. I'll leave that up to you to decide. If you do bring it into your test, you're responsible for it. This is kind of always the case with any kind of additional ideas in your animation. But in this case, if you don't, if you just keep a more basic, straightforward test, that's fine as well. So notice here how that second arc, because the leaf kind of, the shape of the leaf, you feel a little more resistance in it. That's all, of course, done in spacing. And also these loops there, the leaf is moving kind of more perpendicular to its direction, and that's causing a different relationship to the air it's cutting through. This is a really nice one. And you'll notice when it gets really slow, you know, it's subtle, but it's so impactful. Is that like right here as this gets really really slow? Look at how it just shifts a little bit out of its arc, and that gives it a little more of an organic sense to it. Um, and then look at how, of course, also how it hits the ground at the end. Um, in contrast, here's a test that I also say for spacing is a very good test, but it does suffer a little bit from that idea of it being, let me shrink it a little bit so it's all on screen, um, from it being um, a little mechanical, right, sticking to its arcs a little too heavily. Good slow and slow out has a nice sense of lightness in that regard, but you can see how I'm talking about here that it does feel like it's on a track. It's more of like a roller coaster ride than kind of a leaf falling through air, um, but still nice. And this one, and the reason is as it gets to those, you know, no matter what, when you go through the arc, it's going to really get through the fast part, I should say. It's going to get locked into its arc again, unless the shape starts affecting it. But when it gets slow is when you have the opportunity to do something a little more mechanical. If you look at this one, it really does stick in its arc the whole time, and that's why it feels a bit more mechanical and less organic. Um, one more time. Still a totally acceptable test, but that is something that can be complained about it. And again, looking at this one, and again, notice how organic it feels because it does feel like it's in a loose set of air that could, you know, kind of move in many different ways. It has a slight organicness to it, which makes this actually quite an exceptional leaf test. Um, all right, good luck. I look forward to seeing your tests.